This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Hey, and welcome to IAQ Radio Plus episode 620. This week, we welcome Steve Caulfield, the president of Turner Building Science and Design. We're going to talk about building science, moisture, and the Green Book, recognition, evaluation, and control of indoor mold from the AIHA. Before we get started, let's thank our sponsors. They are the reason we can continue doing the show. Please support our sponsors and let them know you appreciate their support of IAQ Radio Plus. Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association at AIHA.org, the American Conference of Governmental Industrial Hygienists at ACGIH.org, the Cleaning Industry Research Institute at CIRIScience.org, the Indoor Air Quality Association at IAQA.org, the Restoration Industry Association at restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification at IICRC.org, and Healthy Buildings America 2021 at HB2021-America.org. Industry sponsors are AEML Laboratories at AEMLinc.com, Particles Plus at particlesplus.com, Gray Wolf Sensing Solutions at graywolfsensing.com, TSI Inc. at tsi.com, and Healthy Indoors Magazine at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to John Lapotere, Florida Indoor Air Quality Solutions in Orlando, Florida. John was first to identify Sollozzo as the man who stabs Don Corleone's enforcer's hand onto the bar in the movie Godfather 1. The IQ Radio Trivia question for today, Friday, March 19th, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IAQ investigations at tsi.com. Here is today's trivia question. Name the written work in which Holden Morrissey Caulfield, one of the most important fictional characters of the 20th century, first appears in print. Back to you, Joe.
Thanks, Cliff. Okay, Steve Caulfield's with us. He's got 30 years of experience in mechanical engineering, industrial hygiene, and indoor air quality studies. He's also very skilled in the design and evaluation of HVAC systems and the relationship to complex indoor air quality problems. He was an editor of the newly revised Recognition, Evaluation, and Control of Indoor Mold, also known as the Green Book, and he volunteers a ton of time to industry organizations like ASHRAE, the Maine Indoor Air Quality Council, and the ISIAC Group, International Society for Indoor Air Quality and Climate. Steve, welcome back to IAQ Radio.
Hello, Joe.
Great to have you back, my friend. It's been 8, maybe even longer, 10 years since we had a full interview with you. You've been known for combining your knowledge of building science and industrial hygiene. You've got the PE and the CIH. Tell listeners a little bit about how you got involved in this industry and why.
Yeah, so I went to college for mechanical engineering. Got out at a bad time in the job market, and I think as you and I were talking, we ended up on the same track. I ended up my first job in the industry, which was my first real job coming out of college, was analyzing asbestos samples, looking at a microscope 8 hours a day. And I managed to parlay that into a whole host of other industrial hygiene things for about 10 years. until I moved up here to Maine when I could start using mechanical engineering. So I really, my work career was industrial hygiene. My education was mechanical engineering. So I've had a chance to do both. And I think, you know, working in IAQ really combines the two of those things really well.
It really does, and it's vital to have someone on your team that understands mechanical systems. They're so important when it comes to, you know, indoor air quality. I think it's a great combination to have. What about people that are just kind of starting out in this business, Steve? Any suggestions for those kind of people?
Yeah, I guess, you know, I had a lot of opportunities when I started out, but most of them were not pleasant. As you remember, in the 80s, there was an awful lot of asbestos abatement work going on and all kinds of other things. I was working for a company that had 3 CIHs at the time. And, you know, we had work coming in that wasn't just asbestos work. So whenever it was, whether it was in the middle of the night or whether it involved taking another course to learn something else, you know, I just said yes. And I'd say, you know, if you just, when there's an opportunity, just say yes, particularly if it comes with free training, like, oh, we need to monitor asbestos in the nuclear plant, but you need to go through a 3-day training on radiation safety. It's like, yeah, so big deal. You're going to pay me? Okay, I'll do that. And I mean, that's been my mantra. I mean, some of the jobs were really crappy, you know, crawling around in places, working in tunnels, working in the middle of the night, but you learn stuff by doing it. So,
and those are the ones that you kind of remember the most too, I think.
Yeah, yeah. The scariest thing, there's nobody from OSHA on here, is there?
I don't believe so.
The scariest thing I ever did was do an asbestos inspection in this mechanical room when the workers, instead of putting up scaffolding, they had boards hung from pipes with duct tape. I was a lot thinner then, but I had to go up about 25 feet going through these catwalks of boards hung from duct tape in a wet environment to do an inspection. Wow. That was probably not the best visual inspection I ever did of an asbestos abatement project.
You got in and out on that one.
I'm live.
So let's talk a little bit about the revised Green Book, Recognition, Evaluation, and Control of Indoor Mold.
Yeah, I'll show you my copy because mine still says Don Weeks and Brad Present because I didn't get a copy of the one that I was involved with.
You didn't get the second edition, huh?
No, I don't have the second edition. That costs a lot of money.
Yes.
But in reality, I told you, Joe, I had very little to do with this. You know, my name's on there because Don Weeks said he didn't want to do it this time. So they needed a fall guy to look through the, you know, the inspection and building science stuff. And I guess I did that, but you know, I don't feel like I put that much into this book.
It seems like the biggest changes were in the earlier chapters, you know,
Yep.
the new way of categorizing mold, for instance, and some of the health effects updates and things of that matter. And we had Dr. Miller, J. David Miller on to talk about those. And what we wanted to do with this second show is focus more on the building science, moisture stuff. So maybe we could jump right to this, John, and pull up those 4 principles on moisture from the Green Book. So this is from the section on buildings and moisture, and it's called Moisture Dynamics. And to control water and moisture, it's important to understand those transport mechanisms. And I think that's what we're going to spend a good bit of time talking about today. Liquid flow by gravity, capillary suction, movement of water vapor by air, and water vapor diffusion. Steve, give some general comments on these 4 transport mechanisms.
Yeah, so I mean, liquid flow, boy, that sounds so scientific. Liquid flow by gravity or pressure difference. So what you're talking about is, you know, water seeks its own level, right? That's just it's falling out of the sky or it's flowing downhill. I think we know how to deal with that. Capillary suction, geez, you know, just this week, Joe Stiebrick had a thing about capillary suction. And that happens, and we see it all the time, you know, base of the drywall gets wet and it soaks up several feet. But that's sort of, you could see that happening. And then if you go, the last two, I think, are more important in building science. Not more important, but they're less obvious. And people get wrapped up in that water vapor diffusion by vapor pressure differences. And, you know, there's, you know, God love them, you could do woofy calculations till you're blue in the face. But the reality is the most important thing that people don't see is how water vapor moves by air movement. So when you move the air, we should have, Joe, we should have brought up that famous thing from the Builder's Guide with the piece of drywall with, you know, one pint of water going through by diffusion and 30 by the 1 inch square hole. You don't have to look it up now, Joe.
I might have it handy, you never know.
But you know, that's how I learned 25 years ago when I first met Joe Stiebrick. That's what he put up downstairs here when we had a training course. He put that slide up, and I'm like, really? You can move that much water through a 1 inch square hole just by, you know, a pressure difference. So there's a lot of water in air, and when the air moves from one place to another, the water moves with it. And B, there's a lot of air that moves through buildings that people don't know about. So I think that's in my business, you know, that's where I tend to solve problems, because if there's visible water, if there's liquid water, either by capillary suction or by gravity, you know, if they're getting liquid water, people usually know about it. But if there are air pressure differences and it's moving wet air from one place to another, people don't seem to get that.
And it also moves particulate. It just so happens I had a phone call this morning from a friend doing some final cleaning on a mold job, and he uses a particle counter to get an idea of, you know, what the particle levels are doing as they're cleaning. And he called and he said, Joe, I don't know what it is, but all around this, there's a big, huge chimney in the middle of this, you know, big, huge fireplace in the middle of this big, beautiful home, 2-story fireplace. He said, all around this fireplace, I'm getting high particle counts, and I don't know why. I said, well, did you check to make sure whether the flue is open or closed on the fireplace? And he said, I don't know much about fireplaces, but why would that matter? And I think it goes right to what you're saying.
You're sucking air down the chimney.
Yeah. Those particles were moving with air from other parts of the building, and they were going up and through that chimney. And I don't think people visualize that. How do you recommend people kind of visualize the air movement that would carry both particles and moisture?
Well, it takes some curiosity. And I mean, I didn't start out by seeing airflow, as I call it, right at the start, but just pay attention to little things. I was telling you the other day, if it's a cold day and this happens in my house. I have a 2-story house. If I stand on the stairs and I put my hand up, I could feel the air moving up the stairs, the hot air going up. And if I put my hand down by the carpet, I can feel the cold air coming down the stairs. And once you get that picture in your mind that there's 2 air streams that are just, you know, constantly, one's going up and one's going down, it's like, then you start seeing things like, you know, in the buildings, it's kind of like the Gulf Stream. You know, there's this endless circulation of air that's going on, and you have to be able to disassociate yourself from what is supposed to be happening. Once you can get that out of your mind, you know, I'm pushing air in here and I'm pulling it out there, and it's supposed to go from here to there. Okay, what happens when you shut off that unit that's pushing, you know, at night, you don't turn that on. Now, can the air go this way instead of that way, right?
Right.
And so it's thinking about air can go any direction. And it just depends on the pressures. So then you got to start thinking about what causes the pressures. Well, when you heat it up, the warm air gets less dense, so it rises, right? It's all about physics.
And you were talking, when we were talking the other day, you talked a lot about using smoke to help people visualize that when they couldn't. Can you talk a little more about that?
Yeah, that's why you're here, to remind me of this stuff, right? So, yeah, so we, well, I mean, downstairs from where I'm sitting, we've got basically a whole floor of equipment that we use for various things. And we do an awful lot of work with, we started out with little smoke tubes, the Draeger tubes, you break off the ends. They were, carbon tetrachloride or something that was nasty. But it made a nice visualization smoke. Now we've graduated to other things, but we use an awful lot of theatrical fog. So one of those fog machines you'd get at Halloween to, make everything spooky. We use them for all kinds of things. We'll stick that smoke in the vent system of a plumbing system in a building and see where it comes out. We'll fill a room full of smoke after you tell the fire department to disable the smoke detectors. You do that wrong a couple of times before you get that right.
Very good tip.
You fill up a building and then you use things like blower doors or exhaust fans or whatever to manipulate the pressures and see where the smoke goes. Nowadays we do a lot of that with infrared, but you don't always have a temperature difference to work with. But we'll pressurize or depressurize a building and use either smoke or infrared to see, where does the air flow. And once you do a lot of that work, you get a feel for how it's going to flow, even if you don't have the visualization media of a temperature difference or smoke. You get a pretty good sense. The best thing about using smoke to visualize air movement is when you have a building owner who doesn't believe that, the air from that stink pipe does come in that unit ventilator. When you can put the smoke in the stink pipe and have it go right into the intake.
Yep.
And they see that, they say, oh, now I get it. That's the beauty.
All right, let's look at some case studies here, Steve. You sent us some photos. I think we have to probably give you the control, but I think these will help illustrate some of the things you're talking about here.
Yeah.
All right, so we got case study one, school building
well,
in North Carolina.
It only says one, Joe, because this was part of bigger presentation. I'm just trying to shorten it down for you here.
Gotcha.
We did another case study also, but this was for I forget what IC Best is. It was some building envelope conference. So anyway, set the stage. So this is North Carolina, right? This is one of those schools that they put an addition on it, and then soon after had to close the school entirely. And we were there working with NIOSH. It's one of those, parents are complaining. This is the only time in my career where I showed up and 15 minutes after I hit the ground, they had a news conference. And, there were reporters there asking us questions, and we were live on TV. I'm like, this is nuts. They're asking me what's wrong with the building. And I'm like, we just got here. So it wasn't just me. But we had a whole team from, if you know the people from that do the health hazard evaluations from NIOSH, we had Ju Young, we had Rachel Bailey, we had not Kay, but Jean Cox Ganser was there. There was this whole team, right? And this is what's going on. So they had renovated the school, and they added a huge addition on the next. Don't go to the next slide. No, don't go yet. But on the next slide, there's a floor plan. But the main thing was they had moldy odors and health complaints, right? This is what we get. And reportedly they had high humidity. All right, now John, you can roll to the next one. So this is what the school looked like, all right? The green stuff was all new. And the only existing buildings were really old, and it's just two little pieces. But the whole thing was renovated. But they made this, it's all one story, and it's going to become important later. But we measured the perimeter of this school, and it's about 1/4 mile all the way around the outside of that building. All right. Wow. And this is North Carolina. All right. So bear that in mind. Go to the next slide, John. So the school had humidity problems, right? So what do? They said, well, let's dehumidify, right? That's a reasonable, you know, if you were a remediation contractor, you dehumidify if it's too humid, right? So they put these dedicated outdoor air dehumidification systems. Report I got was $500,000 it cost to put these things in. They were these heat pumps. The slide on the picture on the right is a rack of dehumidification machines of some sort. I don't even remember. And they still had humidity problems, and still had. You want to read the name? I think they're Train, but I can't remember. I think they were like water-to-water heat pumps, is what they were, and they were making cold water to dehumidify. Right now, this is another place where they're shutting off the units at night, save energy, right? So when they shut off the air handlers, they shut off the dehumidifiers. So, and TSI is one of your sponsors. So big shout out to TSI. So one of the pieces of equipment that we brought down to North Carolina was a TSI Q-Track. We didn't bring a lot of them because we were trying to figure out what the problem was and then go back and get a lot of equipment, right? But we brought a little bit of stuff, and one of them was a Q-Track. So we said, actually, I set it up in a classroom way down the end of a wing because we were staying overnight. I said, let's just see what this shows. You know, not expecting anything, but all right, it's an empty school, right? It's an empty school. I'm not going to see any CO2. I'm just going to measure, you know, CO2, CO, temperature, and RH, see if I see anything. Now, I don't have that picture in this presentation, but the next day we download that thing and the temperature stayed the same all night, but the humidity went up. All right. So you put on your thinking cap and you say, what's making humidity at night in a school that's empty without the air handlers running? Right. All right, go to the next one, John. So we started looking at the details. And when we started looking at the details, we saw these, you know, these joists that form the roof that it doesn't show well in that drawing, but they extend out through so that the tails of the joist form that soffit around the outside. And there weren't any real good air sealing details. You know, there's pretty good air sealing going up the wall. There's pretty good air sealing on the roof, but that soffit is kind of a black box, right? And, you know, I go into the details about what was built there, but basically there were no air sealing details. So go to the next one, John. I don't want to spend too much time on this, but basically those joist ends, they just come out through the drywall, right? And they cut holes to fit the joist out through the drywall, and they stuffed a little fiberglass in some of them. But I mean, you were looking at every 3 feet for 1/4 mile, there's a hole.
Wow. Wow.
So we started adding it up, and it was like the equivalent of 4 roll-up doors, you know, that was just basically open to the atmosphere in North Carolina, remember, in the summer. And that's where the humidity was coming from. So every day they'd suck the humidity out, and every night they'd let it back in, and every day they'd suck it out, and every night they'd let it back in. So, you know, it was bad before they put in the dehumidification. It was sort of tolerable, but it was just kind of, it's almost like, you know, the cases of COVID have gone down to 50,000. It's like, you know, we haven't solved the problem, but it's not getting much worse. So But I mean, there were holes and rips and stuff in the drywall. Anyway, go to the next one, John. And like some of the block walls didn't even come close to the, you know, where there were block walls that were perpendicular to the roof. They don't even come close to the roof. It's just, you know, you could throw dogs through there, never mind throw cats through those holes.
Wow.
So there were just a lot of openings around the outside. So if you go to the next one, oh yeah, and then we brought out some, you know, smoke to do tracer and do some pressure measurement and use some blower doors and do all the fancy stuff that they pay us for, right? And then go to the next one, John. And so then we said, look, the upshot is you got to seal all these holes or you can't keep the humidity out. You're basically trying to dehumidify most of Greensboro, North Carolina, right? So we had them caulk on the left. The picture is, you know, caulking around small holes, and then, you know, to give us sort of a something to spray against for where there were big holes. And then they, you know, went around and sprayed foam insulation inside that soffit all the way around the whole building. Now, to do all of that cost, I think, $100,000 when they'd already spent $500,000 on something that didn't solve the problem, right?
Right.
So that's pretty typical. So
although the nice thing is, once they did this, that mechanical upgrade they made probably made things pretty nice.
oh yeah, and their energy bills go because, you know, they were air conditioning most of Greensboro, North Carolina. So it's one of those things where you have to think about where the air can come in or go, and if you start thinking to yourself things like, I took relative humidity measurements and there was no source of moisture if the temperature didn't change. So this is another little thing. In building science, we don't actually deal in relative humidity much. We were actually looking at the dew point, and the dew point went up because the dew point is independent of temperature, you know. So if the dew point goes up, the amount of moisture goes up. Dew point's a measure of moisture in the air. So what we were seeing was that the dew point went up overnight, which told us there was more moisture in that building when there was nobody and nothing generating moisture in that building. And believe me, we went through and looked at all the bathrooms, made sure there weren't leaks, and we looked at, you know, are there showers, are there whatever. There was nothing to generate humidity. It came from outside.
Steve, I've got a text question, then I want to go to halftime. This is the Green Book is like the Bible. And then he said, his biggest concern that mold measurements do not answer the basic questions and commonly result in over or under reactions. Has that been your experience?
Yes.
Pretty simple.
I'll say. And you and I talked about the fact that, you know, we wish there was more, and you know, this is part of my fault because I'm the one who was the editor on the book who was supposed to put in more building science stuff. But I mean, really, you can go back to the 80s and pull out this book if you really want to know how to conduct an air quality investigation, right? It's all in there. You know, looking at pressures, talking to people, doing an evaluation, all the forms and everything. I mean, it hasn't changed. So, but yeah, the point is perfect. People get all hepped up about what their mold results are, and they should really be looking at what does that tell me? You know, does it really tell me anything?
And how do we fix the foundational problem here, which is moisture?
Yeah, and right. And the tests should be done to confirm or deny some theory about what the moisture is doing. If you're going in and testing first, you still have to find a moisture source. You should be going in and looking for a moisture source first, and then perhaps testing. Although, you know, there are certain circumstances, legal, insurance, things like that, where testing is required up front. But if you're trying to answer a
Public
question,
relations too, you get the school districts, they need some kind of numbers to show people. People are used to that.
yeah, but the number, we all know the numbers don't mean anything.
Yep.
Well, I mean, they need an awful lot of description, of explanation. And generally, what I tell people when they want me to test first, I say, okay, here is the thing. You need to think about, what are you going to do when you get the results back if they say A or B? And I'm going to tell you right now, they're not going to say A or B. They're going to say something that's in between A and B. They're going to be gray. You want black, you want white. This is gray. That's what the samples are going to say. And I'm going to have to explain myself out of this once I take those samples. So why don't we look for moisture sources first, and then maybe, if we can't find anything that way, we'll test in a way that will tell us where to look for moisture sources.
Hey, well said, Steve.
All
We're
right.
going to stop and thank our sponsors for halftime. And when we come back, we'll go into that second case study with Steve Caulfield.
Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at instascope.co. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World at AIHA.org. ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science at acgih.org. The Cleaning Industry Research Institute. See more deeply through science and research at CIRIScience.org. The Indoor Air Quality Association, promoting the exchange of indoor environmental quality information through education and research at IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, network with leaders at restorationindustry.org.
The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry at iicrc.org. And Healthy Buildings America 2021 in Honolulu, Hawaii, November 9 through 11 at hb2021-america.org.
IAQ Radio industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee at aemlinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us at particlesplus.com. Gray Wolf Sensing Solutions, over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring at graywolfsensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations at tsi.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers at healthyindoors.com.
Okay, we're back for the second half of our interview. We've got Steve Caulfield. And Steve, let's go into that second case study. John, can you pull that up for us?
Yeah, it's less of a case study, but you and I were talking about, let's go the other one, John, first. Okay, so you and I were talking about what we've done for COVID. So, we've been because we do mechanical engineering and indoor air quality, we've been doing a lot of building evaluations, both commercial and institutional schools for ventilation systems. So this is one of the ones we looked at. And, part of what our company does, besides all that, is we do an awful lot of commissioning. And when you get into mechanical commissioning, you realize the first thing you do is not to trust the control screens. And this is one of the reasons why. So I was in the office. I wish I had a shot of the control screen. I thought I took a picture of it, but I didn't. I'm in the office and we're looking at this unit, this train ERV that's on the roof of an elementary school back at the office, 5 miles away. And it says, the outside air damper is open. The end switch has proved the outside air damper is open. Those of you mechanical engineers understand what that means. And the airflow through the outside air damper is 7,070 CFM, right? So now go to the other picture, John. This is what happens when we open up the door to this air handler. That's the outside air damper. That thing's closed. The bottom is the exhaust. What you're seeing that angles kind of bottom right to top left is the air exchange wheel. So that's what's exchanging heat from and it's an actual Sunco wheel from exhaust to outside air. But that outside air damper was slammed closed. I cannot explain it. We had 3 pieces of data on the screen that said it was open. But I told the facilities manager, "No, you hired me to make sure that your ventilation systems were working right. Get out the ladder. Let's go on the roof and take a look at it before I leave town and write you a report." And good thing we did, because they had 2 of these ERVs installed 2 years ago. Both of them, the outside air dampers were closed. No reason for that. There was no temperature lockout or anything. The controls thought they were open, but until you go up there and look at it, the whole elementary school was getting no outside air. All right. So This is, this says several things. It's good that, people are thinking about ventilation due to having a pandemic. But it also brings up the point you can't believe what's on the computer screen telling you that everything's all right. So anyway, that's one little story. Then I was doing the same thing in another school system. And John, the picture should be 1, 2, and 3. Yeah, so this is 1. So this is well, I don't want to use any profane language, but this is some kind of crazy unit ventilator, all right? This must have been the cheapest bottom of the line unit ventilator these people bought like 14 years ago. So the way a unit ventilator works is the air comes out the top of that and the air goes in the bottom above that little piece of wood where all the chicken wire is to keep the kids from kicking in there, because they had an ion generator in there, which maybe we'll get into later. Yeah. But in this room, the outside air comes down that little duct. Zoom back out, John. Comes down that little duct from way, way up. All right. So that's the scenario. Go to number 2. So this is what it looks like inside. And, the return air is coming in the front, and those things in the back are the outside air dampers, which, again, on the computer in the guy's office, say we're getting 100% outside air. If you go to the third picture, John, it's a little closer up view of those. So those outside air dampers, they don't close off the return. They open or close, and they open up a slot that's about 2 inches by about 1 foot. So there's 2 slots. So you've got, what is that, 1/6 and 1/6? It's like 1/3 of a square foot, right? It's a very small opening. And remember the first picture, the duct goes all the way up the wall and out through a louver that, that goes to outside. So if you were the air and you were going into this unit ventilator, would you go through the chicken wire and through the fan and get blown up? Or would you come all the way down that duct and get sucked in? You don't have to think about this. It's physics. The pressure drop is too high on the outside air for any of the air to come in through the outside. So even though the damper says it's 100% open, and it is 100% open, you're still not getting any outside air. And the guy was flabbergasted. He's got 27 of these things in the high school. And he's like, well, you're here to do a ventilation evaluation. You're telling me I'm not getting any ventilation? I said, I'm telling you, you're not getting any ventilation. Well, what do I do about that? Well, now that's a conversation we can have. But, you know, this is really good. I think this is, for those of us in the air quality industry, this is a watershed moment when we should seize the opportunity to push ventilation and filtration as hard as we can while there's billions and billions of dollars out there that are looking for a home.
Great point, Steve.
Yeah.
Cliff, do you have a follow-up?
I do, thanks. Steve, you know, you're talking about schools, you're talking about ventilation, you're talking about COVID, and this has become somewhat of a political issue. You have a bunch of teachers' unions that say the teachers shouldn't go back until the ventilation systems are fixed. I think the president, you know, wants to fix the ventilation systems in all the schools before they go back. And the big issue is, I think you've shown several examples of what happens when ventilation systems become new. Ventilation systems get installed, designed, and replaced, and they don't work any better afterwards, and may work worse afterwards than they did before. So I was just asking you to comment on that.
Yeah, well, I don't think we should stop putting in ventilation systems just because there's a couple of bad apples. You know, that I was telling Joe before, that big train unit was part of, you know, an energy saving, I forget what they're called, you know, they're ESOs or whatever. It was a separate contract that was supposed to save energy, not necessarily ventilate. So it could be that the company was intentionally shutting off the outside air to save energy so that they would reap the benefits on the back end of their contract, which was written around energy. And so that, I don't think we should lump that into the whole ventilation discussion. But you bring up another point, is there's no way, I mean, half of Congress is saying, well, we already approved all this money, how come you haven't spent it yet? And I was just on the phone before I got on with you guys talking to a facilities manager saying, what do you mean you need to spend all that money by September of 22? We can't even, you know, we can't close off. You need equipment all over the school. We can't close off the whole school for a year and a half to put it in, but that's what it's going to take. You know, so somebody has to put some thought to this and say, okay, if you have a project in the works, you can allocate that money so that we can get ventilation, which is going to last for 20, 25 years, and spend the money over a little longer period of time. Because a lot of the things that money has been spent on short term are really, they may be doing more harm than good.
Steve, let me ask, I got a text question.
If I can get into that subject, Joe,
Okay.
when you're ready.
Well, I got a text first. Are these ERUs, were they economizers? Are they controlled only according to temperature differences or enthalpy differences?
No, no, it's not an economizer. This is 100% outside air and 100% return. So when the thing runs, it should be all outside air.
It's just temperature based when it runs, right?
Well, I mean, it tempers the air. So these are units that have heating coils, and these actually had air conditioning as well. It'll do everything to temper the air going in. But that particular unit was just, this isn't an economizer. This isn't variable. It's 100% outside air, or it's closed. You know, at night it's closed, during the day it's open. These are just, you know, you turn on the school, the outside air and the exhaust open, and the air goes, you know, in and out all day. This is not a variable control system like an economizer.
Okay.
I had to deal with a whole bunch of those too, but I thought that was a little complex for, you know, we talk IAQ here.
No problem. Hey, we do a little bit of energy as well, so
okay,
not an issue. And that's I guess my next question. When I deal with schools,
yeah,
typically I'm dealing with the maintenance group. good guys trying their best to, take care of problems.
Yep.
There seems to be this push and pull between the maintenance guys and the energy guys that have been hired to save money.
Right.
How do you walk that tightrope, trying to get the energy guys to understand we also have to deal with not just saving money on energy, but we also have to deal with indoor air quality?
Well, some of these schools, it's not that hard because the code requires more ventilation than what they're getting. So, they're going to get ventilation anyway. But I mean, we're always using energy recovery in some form or another. And nowadays you can get energy recovery systems that are bringing, they've got efficiencies 70% or better. So you're really not impacting energy so much by providing ventilation. You're discounting that by recovering the heat and moisture that you're exhausting. And this is a perfect application for schools because schools need so much ventilation. There's so many people per square foot when we're fully occupied, that the ventilation load is what drives the mechanical systems in schools. In commercial buildings, it's much less. You can get by with 10, 15% outside air. But in schools, at least up here in the Northeast, most of the schools we're designing, the total air is the outside air. They're getting 400 CFM per classroom and it's all outside air. So we have to be stewards of the energy as well.
That's a good point. Hey, I want to ask one more question before we go to the roundup. You guys at Turner, and I know Bill Turner, who's I guess retired or semi-retired, he still seems to volunteer a whole lot, like Don Weeks. But you do a series, assist with the series for construction, for contractors who are building new homes and so on and so forth. And I'm just wondering, I know you talked to Bill a lot and you probably helped out with that a little bit. What are the main things that we need to get through to contractors, to general contractors? And you're up in Maine, and I'm here in what I like to refer to as Pennsylvania, where the newest building stuff hasn't maybe caught up to the locals here. What are the big things that you try to get through to people during those sessions?
Yeah, so I guess I don't run it, but I'll give a little plug. We changed the name of it this year. We called it Build a Better House, I think. But it used to be the Residential Construction Training Series, and Bill Turner and his buddy Dave Johnston have been doing that for years. Dave's a builder from way back, so they have the building science and the construction knowledge. But my big thing is contractors don't understand the difference between air sealing and insulation. So they pile more insulation into the attic, and then they wonder why it rains when somebody cooks pasta in the kitchen. And it's because all that humidity goes right through the insulation up to the roof deck, condenses, and falls back down as rain. And, you have to look at, it gets to that moisture moving by airflow rather than, moisture moving by gravity. That's the problem. And it's not diffusing through the insulation. It's moving right through the insulation. The air just goes right up there. So you need to have an air separation between where you live and the outside. And in a house with an attic that's cold, that attic's outside. So you need an air barrier completely across the underside of the attic space. And it has to stop vapor too.
I think if we could just get contractors to recognize that open face fiberglass insulation is not an air barrier, I think that would help a whole heck of a lot, Steve.
Well, what if you stuff more in, Joe? Does that make it an air barrier?
I mean, when I looked at your case study, I've done probably 10 similar jobs where you go in and you look at the intersection between the roof and the wall, and they've got fiberglass stuffed up in there as if it's an air barrier, and and you can see how black it is, so you know how much air is coming through that stuff.
Right. It's a good filter. Yeah.
It is a good filter. All right, let's go to the roundup. We've got some great comments coming in. I think we'll give you a chance to catch up on the comments when we go to the roundup here. All right, let me first start with Cliff. Cliff, I got some great comments here. People can read them on their own. But first, I want to give you a chance. Do you have a final thought or question?
No, I don't. I was just going to turn it over to the audience and just take one of those. So.
Steve, have you had a chance to look at any of these?
Oh, no, they're flying by fast, aren't they?
They are. And I think I want to go to one Ed Light put in here because I think you'll agree with Ed on it. I'm just going to go back up a little bit and find Ed. Yeah, here we go. The number one thing that schools should do with the COVID billions is to check all the points in the system and restore the ventilation and filtration to intended levels. I think that's an interesting comment. I wonder what your thoughts are, Steve.
Yeah, I think the recommendations for superior ventilation that are coming from ASHRAE and from CDC are good, but I think the reality of those of us who've worked in schools is if we could just get them to the point where they're working, we'd probably have much less virus transmission, but much better test taking ability and much better concentration. And I think in a lot of cases, Ed's a little more positive than I am that the equipment's actually there. We're looking at one school designed in 1990 that was designed for 5 CFM a person. It's not what's there according to the design documents isn't good enough, but I think we should, yes, I think it's going to be important to spend that money wisely on something that's going to last, like providing good ventilation and filtration.
Interesting. Steve, I got a question that I don't know if I even prepared you for this, but let me throw it out anyway. What are some of the kind of, other than COVID, up and coming indoor air quality related issues that you see?
Okay, so I'm going to go there now, Joe. Okay, because it's gonna come out of COVID. The folks who do indoor chemistry, so the Delphine Farmers and the Shelley Millers and the Richard Corseys of the world, are really going to start looking at ionization devices and what effect they actually have in buildings. Because I told you, I was looking last night, that so far over $60 million of the COVID money has been spent on ionization devices because you can buy them off the shelf and put them in the air handler right away. But what I've come to realize is that the marketing has all shifted, and now those devices are marketed as physics rather than chemistry. So they're telling you we're going to make positive ions and negative ions, and it's sort of like a magnet. They're going to be attracted. They're talking about physical forces. They're going to plate out, right? But that's not what's happening. They're making electrons and protons and doing chemistry in the air. And we don't know what's coming out of that. And the folks who do indoor chemistry are going to start looking at that. I've seen the chatter on Twitter. And it'll be interesting to find out what's going on because truthfully, those folks who are producing those devices, they measure what they want to measure. So they see what's here. I've got bacteria. When I use my thing, I don't have bacteria. But what do I have? They don't look at what do I have. Or in the classic case of the hydroxyl generators, they would say, well, we have formaldehyde coming in and we don't have formaldehyde coming out. Like, you've still got a VOC. It may not be formaldehyde. But what it is something that's not regulated, not studied. We don't know what the health effects are, but it is another chemical because you didn't just ungenerate that matter. those those molecules went somewhere and the atoms attached to something else. So, and the other thing I'll say is, I looked up their study that says they removed 99% of the COVID in a sample. The sample is 1 cubic foot, and it takes a half hour to remove 99% of the COVID. So if you take a classroom that's 7,200 cubic feet, 900 square feet by 8 feet tall, that means it takes about 4 months to remove all the COVID. If you just extrapolate 1 cubic foot to 7,200 cubic feet, I'm not sure that the studies that they've done really show that those things work the way they say they do. There we go. That's my rant.
I appreciate that. I've got a quick question that's kind of related to a text that came in before we go. The text was that you want to bring in your outdoor air from low and take it out from high. So low and slow, as John Hale would say on the CIH. This was a private text that came to me. And I understand that's similar to what you would call displacement ventilation. And you've had some luck in getting school districts to go ahead and put together some nice displacement ventilation strategies in schools. I wonder if you could comment on that.
Yeah, so Bill Turner went to Indoor Air 93 in Helsinki and came back just enamored of the displacement ventilation in Finland. And he was the one who realized that schools are a perfect place for this, because displacement works by using the heat in the space to drive the air from low and slow to exhausted up high. So every person and every computer in the space, and you got a lot of people in classrooms, they drive the airflow. So you can use smaller fans to deliver air at a lower velocity down near the floor. It's at room temperature or thereabouts. It's all outside air that's been filtered. And it sheets up your body because your body heat is driving the air up. So you're breathing fresh air all the time. And everything you breathe out and all your body odors and everything go out through the exhaust up in the ceiling. So we've implemented this in about 40 schools in New England. And people just love it. The energy efficiency is there, but the fresh air is there all the time. That's all you get is fresh air.
Absolutely. I tell you, Steve, it's been fascinating, and we actually did it in an hour. I was a little surprised. I wasn't sure we could pull it off, buddy.
I told you had to rein me in, and you did. Thanks.
I did it, man. Cliff, final thoughts from you, Cliff?
That was great. I appreciate
All right. I want to thank you,
particularly the comments on the ionization and stuff, because
we were
we get a
reminiscing
lot of
and,
questions on that.
Yeah. We actually met years ago at Steve Brooks. I happened to sit next to Steve at summer camp, and I've enjoyed talking ever since, Steve. Thanks for joining us today.
Well, you're a great guy, Joe. Thanks for having me.
I also want to mention that Steve mentioned Delphine Farmer, and she's going to be on with us in 2 weeks. We're going to talk more about home chem and more about some of the new bells and whistles, filtration and ventilation type stuff that's being sold on the market. We'll talk a little bit more about that in 2 weeks with Delphine. Next week, we're going to do a flashback, and we've got a couple other great shows coming up. I want to thank my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. This week's guest, Steve Caulfield, president of Turner Building Science. Most importantly, our growing group of loyal listeners and our sponsors. We'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.